Okay, so we're going to start with the create, and we're going to see how we can handle a database error, something that only comes from the database. So actually, before I even get into the code, let's run our application again. The domain level constraint that we can probably use to demonstrate this most easily is our OHIP number, the unique constraint on that. No two people can have the same OHIP number. So remember, we very wisely took it off the index page, but it means I have to click details to go and find out. So Fred Flintstone, okay, his OHIP number is right here. I'm going to copy it, go back to the list, and I'm going to create a new patient altogether. But I'm going to use Fred's OHIP, right, which of course should cause a violation of that unique constraint. Now I'm never going to be able to do this, so I'm not going to take time, putting a lot of data in here, right? I have to put enough to satisfy validation. Okay, we'll maybe say 1 or 2. I have to put a phone number in, and I have to put an email in. And oh, I get a chance to show off my selected doctor. See, you must select a primary care physician because the range of that was 0, or the value was 0 outside of the range. Okay, let's pick a doctor, any doctor. Now I can click create, and yay! Look at all this wonderful feedback, right? It's just like I talked last term. It's wonderful when you get these error messages, because what does it tell me, right? An unhandled exception occurred. Well, this is the kind of thing we love to see, but we definitely don't want the end user to see, right? So this is the message actually coming right from the database, okay? Cannot insert duplicate key in row, with unique index. All right, so that's kind of a key piece of information. IX patient OHIP, okay? So that's what I was getting about earlier. I mentioned we can look at the specific information carried in the exception back to us and know exactly what's wrong. So I could search for something like this name of a constraint, and then I know for sure exactly what the problem was, and I can tell the user, hey, you can't have a duplicate OHIP number, right? The other thing to note here is it tells me the type of exception to look for, a DB update exception, okay? So when I do my catch block, I know what kind of exception to look for, because remember, we could just say catch exception, and it would catch everything, but I want to be specific and look for this type of exception, right? Okay, so that's something I learned just from getting the error message up on the screen. So that's a good thing. So let's come to our controller for our patient, and we're going to fix that. But maybe before I do, we haven't spent much time looking at the code inside a controller. So let's take 5 minutes and talk a little bit about it. Okay? We notice it inherits from a class called controller, so it gets a lot of smarts and capability from that parent object, right? We have a private read-only context object based on our medical office context, okay? But that gets actually passed in, right, in the constructor. That's a change from, last year when we were teaching this with .NET Framework, we would actually just hard code creating one right here in the class level, right? Now this is a form of dependency injection. So we pass in a context that lets us fake it later on. If we have it make a fake object, as long as it implements the same interface, we can just pass it in here, right? Okay, getting past that, now we have a context to work with. So these action results, we've talked about them before. Notice everything is asynchronous now. We've gotten away from doing synchronous inside our controllers. Everyone know the difference between sync and async? No. Okay, good. All right, bears a discussion then. Basically, synchronous programming means everything has to happen in order. And if your code gives a command for something to happen and it takes a little while, then it's going to sit there and wait until whatever it's asked to do is finished its job. And only then does it go on to the next line in your code, right? That's synchronous. Everything is done in order. So if that's a long process that it is asked it to do, the code just sits there and waits and nothing can happen. So, if there's a user interface involved, it'll just be sitting there, it'll appear locked up. You sometimes see it not responding in the title bar of an application. That's because it's doing something synchronously, right? So the application can't do anything else. It can't respond to anything until that previous line of code, whatever it asks to have done, is finished, right? So asynchronous it uses multi-threading. You might have heard that term, Right? All of our CPUs support multi-threading and so on and so forth. So what it does is it starts a separate thread to go off and take care of the job it was just asked to do, but in the meantime it can go on and execute other things. And then it just gets notified when that other job, that outside job perhaps, is finished. It just gets a notification, right? So it allows your application to keep on working and running and being responsive in the meantime. The downside of asynchronous is, of course, think about if it tries to do something that it really can't do until you get the result back, that can be a problem. You have to write code to actually handle the event of being notified that the asynchronous process is finished. And it used to be a real nightmare to write asynchronous code. But now they've made it so easy. All we have to do is use things like an await operator, right, here and there, and then asynchronous works beautifully. The internet, because of the delays in transferring data around the world sometimes, definitely works better, right? Your application will work better using asynchronous calls. Also, the other thing it does, because it doesn't tie up the server, right, with one process, it allows much more scalability. So your application hosted on a web server somewhere can handle a far greater number of users if you do all the programming asynchronously. Fortunately, we hardly even have to worry about it anymore. They've made it so easy. All we do is say async, and sometimes you have to say await, right? And that's about it. Okay, anyway, getting back to this, so we have an action result called index that just returns the data to the screen, right? So here, this is all the includes we added yesterday to support our many-to-many, so we could show the different medical conditions that they've had in their medical history, right? We have one details action result. This gets the data ready to show that details page, okay? And then down here, then we have six action results, right? All related to our three action queries, basically. Our create, corresponding to insert, our update, and our delete, right? I say there's six because every one of them is in a paired arrangement. There's one for the get request and one for the post. You may or may not have ever talked about it, but best practices for the internet is you should never update data based on a get request. It's just too vulnerable, too dangerous, right? So we should never do that. We should do it on a post instead. Remember the difference between a get and a post. You learned that right with your first web course, right? So what we'll find is we have a create and a create here. Okay, we have duplication, right? Two different methods called create, or action results called create. The first one, because we haven't specified otherwise, responds to all the get requests. Then down here, notice we've decorated with an annotation here, HTTP post. So this version of create responds to all the posts, right? So if we have an HTML form, you click the submit button, you post the data up here. Okay, so that's why they're paired. One is for the get, one is for the post. Now we are allowed two different action results or methods here called create only because the signature here is different, right? That's basic object-oriented rules. You can have two the same, but polymorphism means the signatures have to be different, right? That's okay. So let's think about what in the get, all we're doing is we're preparing that drop-down list, the data for the drop-down list, and saying return view. No data supplied. The brackets are empty, right? Because it's going to be a blank form, right? The create view is just a blank form to type all the data in. So we don't have to pass any data to it initially, other than what we're going to throw in the carry-on luggage so it can populate the drop-down list for the foreign key. Now we come to the post. Let's see what's happening here, okay? Notice that there's a check here. We're looking for a valid anti-forgery token. So that's built into this whole process. If you're not sure what forgeries are, basically to make sure that the request you're getting back, or the request you're getting back is in response to what you just sent them, you generate this anti-forgery token and you tuck it in the page. That way it's hard for people to intercept and fake that they're sending the data from your in a direct communication back and forth. It's just one of the many types of hacker attacks out there. So it's great that it's already built in that we have protection from that, right? Now we get down here, we create, well, what are we going to pass in as values? Well, we'll talk about the keyword bind in a second, but the point is, what this does, it uses a default model builder. Okay? You can actually substitute if you want to. I've never seen anybody need to bother. it's extensible system. You can supply your own model builder instead. But there's a built-in one. Basically, what I'm saying is, take the data coming in and construct me an object based on the patient class. So it automatically looks for all the data coming in. Actually, it'll do this whether it's a get or a post, or whether it's in cookies or whatever, right? It'll pull all the data available in the request together and see if it can actually build or construct an object of this class. So if you have a first name, it matches it to the first name property. If you have a last name, et cetera, all the way through. So it'll actually construct an object, so I'm calling it small p patient here, okay, that I'll build with the data coming in. So that's what this bind expression for. This is a white list, okay? You can have a black list or you can have a white list. So what it's saying is only values with these names, okay, because it all comes as name value pairs from any standard HTML form, right? Name value pairs. So as long as you have information with these names or identifiers, then we're going to use them or allow them to be used as we construct this patient object. What that does is it protects from, I think it's even up here, yeah, to protect from overposting attacks, right? That's what this bind is for, right? This whitelist. So overposting, what that means is some hacker out there might guess that you have an additional property in your object, in your class, that isn't exposed here. And if they can guess the right name, and believe me, hackers spend a long time guessing at these things, they can use any tool like Fiddler or a whole bunch of other ones to go in and intercept, okay, between a request and a getting to the server and add more data, right? So they could overpost and try to, and if they guess right, they'll supply data that would be used as you construct this object. So it's just yet another hacker protection that is built into the system using a whitelist like this, right? The only downside is if you come along later on and add a new property to your patient, you got to remember to come over here and add it to the whitelists, or you'll never get that updated from the client, right? So it does, put a little, it's not exactly dry, but it does help protect against that. Okay, so what happens next? Our next if here checks for validation. Remember I said a minute ago, all validation is double checked on the server, right? So as we construct that object, we'll have a model state that we're maintaining, and we'll see if it's valid, it's true or false. So if all the validation requirements in the annotations, and of course now with our new iValidatable object, right? If any of those are complaining, this will return false. What happens then, it skips over all this. We just populate a drop-down list, so we have the carry-on luggage carrying the information for the drop-down, and we return the view again, so they'll get the create view back again. This time though, we're passing the actual patient object, right? So they'll get back all the data they just typed in. Otherwise it's really, you piss off your pardon my language, you would really frustrate the end user if they type in the form and just because there's a validation message they have to type it all in from scratch, right? So that's how we get the data back on the screen that they've already entered. It's not valid yet, so it gives them a chance, right, to fix whatever problem there was. And fortunately, our model state that gets passed back as well contains all the errors, and that gets displayed in the page. So that's the magic that's happening here right now. Pretty good, right? But problem is here, if it's valid and we come in here, look at how easy it is with Entity Framework, right? We don't have to write any insert statement customized for all the fields that we have, etc. All we say is add a patient and then save changes. Save changes async because we're doing everything asynchronously. And if there's an error from the database, that's when it will crash and give us that beautiful error screen we were looking at a minute ago. So that's good for us, but we want to protect from that using a try catch. Oh, notice that also once it successfully saves, we just redirect back to the index action, right? So instead of going back to the client directly, we refer back to the index action, which of course will return the index view, and that gives just the list of all the patients. Probably where you started from to begin with.
Okay, right now I'm writing the information in the database.
That happens right here.
Okay.
Yeah. Yeah, we just add it to the collection, the DB set, and then we save it to the database, and that will actually write it to the database. Yeah. Okay, and then redirect to the index. But of course, if something goes wrong here, we just get that error message screen. So what we're going to do is we're going to add a try catch. Now you've seen me use things like prop and prop full as snippets. Well, there's one for try, T-R-Y, tab, and there we go. There's my basic try-catch structure, right? So essentially what I want to do is I want to move all of this, the if and all the contents, and move it into the try block. Okay. Now, of course, here we just have throw, so when you throw the exception, that means it won't actually handle it, right? If we don't throw it, then it actually gets handled by the try-catch. So that's just, again, a safety net to make sure we actually do something when we catch an exception. So finally, this logic is the same, right? We'll actually redisplay the data if there was a validation message. But in the meantime, by wrapping this in a try, if there's a database error, we'll have a chance to examine it. Now we could just use the exception, but it's better to use that specific one we were given in that error message screen. So I'm going to go to my copy-paste file for a second, which somehow I closed. Okay, so I'll just open that up again. I'm just going to grab the catchphrase, that's a catchy phrase, out of my copy-paste file. Right? So we're going to look for specifically that DB update exception, right? And by giving it a name, it means I can access its properties in code. So what I can then do is check its inner exception, the message, and see if it contains, well, I got that right off the error message screen. That's how I knew the name of the secondary index that was created by the system, right? If it actually contains that message, then the error, the model error I'm going to add to the model state is simply, hey, unable to save changes. Remember, you cannot have duplicate OHIP numbers. This first argument, well, that's kind of the same idea we talked about a minute ago. Whenever we add these model errors, we can specify what element it belongs to so that it will appear right beside it on the screen. Okay.
How do I know the message? Like IX, patience?
It was on the screen a minute ago. I made note of it. Remember, when we caused the error by duplicating Fred Flintstone's. But another thing I could always do, if I didn't do that first, I could set a breakpoint. And then I can stop in code and examine it there, right? So let's do that. So I'll run it again. Okay, so I'll just go and I'll have to find somebody's OHIP number. I'll pick a different person this time. So Jane, I'll go to details, get Jane Doe's OHIP number. Try to create a new person with that same OHIP number. Hopefully okay, I lost count as I was going. Okay, good. Email. Where's my previous values? Strange. Okay, I'll pick a doctor. I'm doing all this just to get the error, right? Okay, so you see it followed through. It hit the database error, so I'm in my catch block, right? So my exception, okay, notice it's also down here in the autos. I can see the exception object down here. I can expand, have a look. Okay, so here's the inner exception, the message. An error occurred, and I can, oh, come on. Okay, there it is. See the inner exception for details. Okay, so I do have to go over here to the inner exception, expand it, which is of course in code why I access the inner exception. Okay, and there's the message. Cannot insert duplicate. Let me bring it up in the, text visualizer. Right, so there's the message from the database. So that's how I could double check that this is the, now I could probably just say IX underscore and not worry about the other keywords because there's only the one unique constraint on the table. But you know, it's probably better if I use the specific one if I know it, right? That's two ways you could find out the specific constraint in the database that's complaining. Okay? All right, so debug mode is your friend. You can find out all kinds of things in debug mode, right? Okay, and I'll just click continue, and there we go, unable to save changes. So it passed that error message back, my catch block, added it to the model state, and noted that it should be right beside the OHIP. Okay, so that's why the error message is showing up there. Okay, so any questions about that? So that's all we really have to do for create. Now, by the way, maybe before we leave this, you know, some people would say, well, you know, we could put another catch block down here just for a general exception in case it's not a DB update exception.
I have one more question. So that IX patients OHIP, that's the name of the constraint, right?
That's right.
So that is a name that I created, or it was like the framework?
Actually, the framework created it. Now you can, when you using that Fluent API, you can optionally specify the name for it. Right.
So if I want to check for another exception,
Yeah.
I have to like make that exception happen so I know the name?
Well, actually, if you even look back into your code for the migrations, you'll see the name that's going to be used there to create it. So there's lots of ways to find out.
Okay.
You can look at the SQL that was run, you'll see the name there. But there's also an option in the Fluent API when you create the constraint, you can actually give it a name then. I just didn't bother. Okay? All right. So we could add yet another general catch block, but you know what? We'll never ever need it. Right? We pretty much know the only thing that can go wrong in the database. So, you know, sometimes we can go overboard cluttering up our projects with code that, you know, you're never, it's not wrong, but it's just overkill, right? So you'll see in most tutorials, this is as far as they'll take it in terms of having the try catch set up. Okay, well, let's stop there.